Okay, we are back. This is the second part of this second video of this problem set. I've already uploaded the first part for you. All right, let's get right to it. Again, what are the steps to doing these? Again, keep, change, flip, right? If that's only for division, keep, change, flip. That's only for division. And then again, factor, cancel, and then multiply across, correct? All right, so let's do it. Divide the following rational expressions and simplify the results. Okay, so we are going to first factor and I'm going to keep, change, flip and also factor at the same time. Okay, so I hope that doesn't confuse anybody. I'll go really slow. So first thing, this is again a difference of two perfect squares. So that's going to factor into x plus 6 x minus 6. Okay, excuse me, that should be a parentheses here. Okay, and then that is divided by, now here, looks like we can take a z out, and we can also take a 5. So we can take 5z, which is going to leave us with 4z minus 5. Okay, and now we're going to change that division into multiplication. We're going to flip it. So we're going to have 5, oops, we're going to have 5z cubed over, and let's try to factor this thing. It looks like I'm going to have a 4, right, as our greatest common factor. And that's going to leave me with z squared minus z minus 30. Okay, which can further be factored, right? This trinomial can further be factored into z minus 6 and z plus 5. Okay, guys? Now, let's look at the restrictions. Now that everything is factored, it should be a little easier, right? This should be clear. Definitely z can't be 0, right? It would make 5z equal to 0. Okay? So z can't be 0. What else? Here, it looks like if we set this equal to 0, z cannot be 5/4. So z can't be 5/4. Here, z can't be 6. It's a comma, by the way. And z can't be negative 5. Now, before we flip this, if you look over here, you'll see that 5z cubed was in the denominator, right? Before we flipped it. Again, the only value of z that'll make this 0 is 0, right? If z is 0. We've already gotten that, right? We already got that one. So we don't have to worry about this one. So these are going to be our 4 restrictions. Now let's cancel. What can we cancel here? Definitely looks like the, why did I put x's up here? Sorry about that, guys. So these are z's. Okay, so definitely z minus 6 is going to cancel with the z minus 6 down here. And this 5z is going to cancel with 5z cubed, leaving us with z squared. Okay, excuse me. And I think that's it. So let's write out whatever's left. So we're going to have z squared times z plus 6 over, it looks like it's going to be 4 times 4z minus 5, minus 5 times z plus 5. Okay, And our restrictions are these four right here, right? So z can't be 0, can't be 5/4, can't be -5, and it can't be 6 here. Okay, 0, 5/4, 6, and -5. And let's check. That is correct. Okay, folks? All right, let's go to the last one. And again, this one looks very similar to the first one that we had in the previous set, right? But we'll do it anyway. Tessa and Kaori, they perform the following operations, and is either of them correct or are neither of them correct? So let's do a quick check. All right, so this is multiplication. Let's use our steps. Let's factor. We don't have to do keep, change, flip. So we can take out a 4. We can actually take out a -4. Use this color here. Take out a -4. Because if we were to take out a -4, then we would just end up with 2n, right? And then 2n minus 1, like that. The bottom is already factored. 11n times n plus 1 times 4n squared over, that's a squared, and then we can take out a -5 again, leaving us with 2n minus 1. Okay, so that is properly factored. And again, we can clearly see what our restrictions are. So I know they didn't ask for it again, but we're going to do it just for practice. So our restrictions are n cannot be equal to 0, n cannot be equal to -1, and n cannot be equal to 1/2. Okay, and I think that takes care of all the restrictions. Now let's simplify. So we have a 2n minus 1 canceling out with a 2n minus 1. Okay, we also have an n here that's going to cancel out with one of the n's here. So that 2 goes away, leaving us with just 1. And I think that's it, right? So let's multiply this whole thing out. We're going to have, it's going to be equal to negative 16n over, and this is going to be -5 times 11 is -55 times n plus 1. And I think that is our expression right here. That is our simplified expression. And again, the negative over negative can be simplified into positives, right? Negative over negative is positive. So it definitely looks like Kaori is correct. And I don't think Tessa is, right? I don't think so. No, she is not correct. Okay, I think she flipped this, if I'm not mistaken. Yeah, that's what she did. Tessa accidentally thought this was a division and flipped the second expression. And that's how she got what she got. Okay, so let's click on Kaori. And that is it. Okay, guys? All right, take care, all right? Good luck on the problems.